Hello and welcome to Maths by El Profelo, doing some elementary number theory. We're actually on chapter 2 right now on a text by James K. Strayer, looking at linear congruences in one variable. And we've got our theorem that says if we have this congruence, then as long as our greatest common divisor of A and M, as long as the greatest common divisor of A and M divides B, then we're going to have a solution, right? And if that greatest common divisor divides B, the congruence has exactly D incongruent solutions. We've got our corollary that talks about the linear congruence, AX equivalent to 1 mod M, having a solution if and only if A and M are relatively prime, and that any solution of AX equivalent to 1 mod M is said to be a multiplicative inverse of a modulo M. Okay? Now, how do we find all the solutions? Right? Well, we can find all the solutions by saying if we have this congruence and we have this greatest common divisor, we know we have a solution as long as the greatest common divisor divides B, and that there are going to be D incongruent solutions, right? So all our solutions would be able to be found, all the incongruent solutions, as saying x naught plus m divided by that greatest common divisor times n, where n is equal to 0, 1, 2, all the way up to d minus 1. And x sub 0 is a particular solution of the congruence. Right? How we find this particular solution is going to depend. Sometimes it's going to be fairly straightforward, and sometimes you'll need to use the Euclidean algorithm. Right? In this first video, we're going to solve this congruence. 3x is equivalent to 6 mod 15, and this is going to be fairly straightforward. In the next video, we'll solve the congruence 16x is equivalent to 8 mod 28. And for this particular congruence, we will need to use the Euclidean algorithm. Okay, so let's start here. So 3x is equivalent to 6 mod 15. We should always first check that our greatest common divisor, which is 3, actually does divide our b. That's true, so therefore we have solutions. Right, so therefore we do have solutions. Okay, now when we have this situation that A is the greatest common divisor of M, or when M is the greatest common divisor of A, right, then we can use our intuition and inspection to be able to say, hey, well, clearly 3 times 2 is equal to 6, which would be equivalent to 6 mod 15, right? So we can say that x naught is equal to 2 is a solution, right? Now, by inspection, if you're comfortable with your mathematics, you would be able to say, hey, you know what? 3 times 7 is 21, and that's going to have 6 left over when I divide by 15. Right? As well as 3 times 12 is equal to 36, and that's going to be equivalent to 6 mod 15. Right? That if I have 36 items and I put them in groups of 15, I'll have 6 left over. Right? And it says that we're going to have 3 incongruent solutions, and so our incongruent solutions would be 2, 7, and 12. Now this was all done by inspection. How could we use this formula to help us? Well, we could use this formula by saying, hey, you know what? What is m divided by d? Well, m divided by d is going to be 15 divided by 3, which is 5. And let me put a little vertical line over here to separate our work. Okay. So what that tells us is that we could have also found our solution by saying x naught plus 15 over 3 times n, where n is going to be equal to 0, 1, or 2. So that's going to give us, if x naught is equal to 2, we could say x sub 1 is going to be 2 plus 5 times 1. And x of 2 is going to be 2 plus 5 times 2. And 2 plus 5, well, that's 7. 2 plus 10, well, that's 12. Right? And if I wanted to say, well, what if I wanted to go to x of 3? Well, that would be 2 plus 5 times 3, which really is, right, which really is just 2 plus 15, which is going to be the exact same solution as if we had x naught was equal to 2. Okay? And so our incongruent solutions are these solutions right here. Right? Now, once again, how do we know we have solutions? We know we have solutions because the greatest common divisor divides b. And how many solutions do we have? We have 3 incongruent solutions. And we would be able to say that really and truly our solutions are going to be x equals 2 plus 15t, or x equals 7 plus 15t, or x equals 12 plus 15t, right? Where t is going to be some integer, right? That if I keep on adding 15 to 2, I'm going to have the same remainder. If I keep on adding 15 to 7, I'm going to have the same remainder. If I keep on adding 15 to 12, I'm going to have the same remainder, right? So these would be our incongruent solution classes, and these would be the forms of all of the solutions, okay? We'll do this next congruence in our following video. Thanks for watching Maths with El Profe Lo.